Welcome to part 2 of the walkthrough for assignment 4. The purpose of this assignment is to deepen your experience using Java functional programming features and their integration with Java reactive streams and reactive microservices. In particular, for this assignment, you'll develop a server app that uses the Project Reactor implementation of reactive streams in Spring WebFlux to create microservices that receive images from clients and return updated images after applying requested transforms. Unlike the earlier assignments, the code you write here will not have its own GUI. Instead, it will be accessed by an Android client app that can either perform all image processing locally on the client device or remotely using the reactive microservices implemented in this assignment that are deployed on one or more servers. Please use the Android client app along with the unit test discussed below to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. An overview of Java reactive streams and a comparison with Java streams is available here, and a tutorial of Spring WebFlux and its support for reactive microservices based on Project Reactor appears here. Naturally, we'll cover all this material in class. The reactive microservices image processing server app is packaged as a project using the latest version of IntelliJ. This app is written in Java and demonstrates many Spring WebFlux capabilities. For the purposes of this assignment, however, you only need to be aware of the following directories: source main Java server, whose main and microservices common folders contain the skeletons you need to fill in, as described below, and source test Java, which is a set of unit tests that exercise key features in the server and can be used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you'll need to use the provided IntelliJ project. You can start all the microservices that are part of this. To compile this code, you'll need to use the provided IntelliJ project. You can start all the microservices that are part of this project by clicking the green Run Microservices button or by starting each microservice independently, both via the IntelliJ IDE. You'll need to modify several files containing the Java skeleton code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks and do not delete the to-do tags. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the source main Java server folder. Main-controller.java and main-service.java are files where you'll need to complete the to-do tasks in various methods to implement an app gateway entry point for remote clients that want an image to be processed by a set of image transforms via Project Reactor classes. Transformer controller and transformer service.java are classes that you'll need to complete the to-do task in various methods to implement a microservice entry point that transforms the image by applying a transform operation, thereby producing a new modified image that's then returned to the client via Project Reactor classes. Your solution should use no loops or no unnecessary conditional statements in this assignment, and instead use the Project Reactor Flux and Mono class operators. Your solution will be considered correct if it passes all the unit tests and communicates properly with the Android client app. Skeleton code for this assignment is available here on my GitHub account in the server skeleton folder. You can pull this skeleton code in your repository, read it carefully, and complete the to-do markers. Unit tests in the source test Java folder are provided to increase our and your confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect problems in your code. This assignment is more complicated than previous assignments since it requires deeper knowledge of Project Reactor and remote communication via Spring WebFlux. In particular, the asynchronous nature of reactive streams and WebFlux may take some time to get accustomed to, so please start the assignment soon and ask questions in class, office hours, and on the discussion forums. As usual, the reactive microservices image processing server app skeletons and unit tests are extensive, though you don't need to understand them all to complete your solution. Now that we've walked through the specifications for part 2 of assignment 4, let's take a look at the skeletons, starting with main controller. This Spring controller is the main entry point for remote clients, which in our case, of course, is the Android client app. It demonstrates how Spring can be used to handle an HTTP POST request asynchronously via reactive programming. This request applies all the given transforms and returns a mono that emits a list of transformed imaged objects. Down here you can see the main controller is defined with a couple of annotations. REST controller indicates it can handle HTTP requests via its endpoint handlers or routers, and response body is an annotation that tells the controller that the object returned is automatically serialized into JSON and passed back within the body of an HTTP response object. There's one field defined here that's an auto-wired field called main service, which connects the main controller to the main service, which we'll take a look at in a moment. And then down here is the endpoint handler method. which applies the list of transforms, which is passed here, to the given image, which is passed here, and it returns a mono that emits a list of transformed imaged objects. And you can see one of your first things you have to do is add the appropriate annotations to turn this into a Spring WebFlux endpoint method, including adding the appropriate annotation to indicate what kind of method it's going to handle, put versus get, for example, as well as the various annotations you have to add for the parameters to make them work properly. I provide you the implementation of this method, which will just turn around and forward to the main service apply transforms method, which we'll look at in a moment. And this method is going to take the transforms list, the original file name of the image, and also the bytes that comprise the image, which is passed over as a multi-part file. What comes back here will be a flux to a stream of transformed images. Due to various bugs with Android's retrofit client, we can't pass back a flux of transformed image objects. Instead, we have to convert it into a list. So we use the collect list method. And what we return here is a mono to a list of transformed image objects. Unfortunately, that bug is annoying, but we haven't found a workaround for it yet. Here's the main service. This class defines various implementation methods, in this case just one, that are called by the main controller, which of course is the front end app gateway entry point for remote clients that want an image to be processed by a set of image transforms. And the service is where that takes place. As you can see, there's a couple of auto-wired fields. One is a web client field, which is used to send requests to backend microservices. And another is a discovery client, which is used to find all the registered microservices. If you take a look down here, you can see we have the apply transforms method. This is what's delegated to by the controller, and it takes in a list of transforms, the file name of the image, and the bytes of the image, and it returns a flux of transformed image objects. I provided you with a little bit of code here just to make things easier to get started with because it's a little subtle. You have to create a multi-value map that will contain the file name as well as something called a byte array resource. And these are objects that will be used to pass to the back end. And you'll have to do that using the appropriate web client methods. Down here, you get to do the fun part. So first you have to call the get transform microservices to get the list of all the microservices. And then depending on how you do this, of course, one way is just to return the list that comes back from the Eureka discovery client. That's probably the easiest way to do it. In which case, then you have to take that list of transforms and turn it into a flux, and then use filter to get rid of anything that doesn't match the transform name in one way or another. And then the final thing you have to do, and this is really the bulk of the code, is you'll have to use web client in order to post a request to the microservices one at a time via the web client, and then go ahead and get the result back. You'll have to pass the map over as part of the body value that you'll pass to the web microservices, and then you'll get back the responses, which you then have to use the appropriate way to turn that back into the appropriate type of reactive type from the JSON, and then you'll go ahead and return that after you get rid of any nulls that might happen to come back. So that's where the bulk of the logic goes here in implementing apply transforms in the main service. Now, each of the microservices that are called are going to be implemented as a transform controller. And this is something you'll also have to do. This is a Spring controller that demonstrates how Spring WebFlux can be used to handle an HTTP post request by using Java reactive programming. And the method that's defined here, the endpoint method, transforms the image by applying a transform operation, thereby producing a new modified image that's returned to the client. Actually, it's returned to the client, which in this case is the API gateway, which will take all those results back and then turn around and return them back to the caller. You take a look here, you can see the transform client is a REST controller with response body, and it has a discovery client, and so on and so forth. We're not going to spend a lot of time on those things. You can read about them up here. What you need to do is you need to fill in a couple of fields. One that's going to connect the transform controller to the transform service. And I guess that's the main one you have to do. And then down here, you have to implement the apply transform method. And what that does is it takes in the transform and it takes in the multi-part file, which is the image. And what you're going to do is return a mono that will emit the transformed image. And this will be done by converting the result of calling service apply transform into a mono that emits the transformed image. And also you have to make apply transform into a Spring WebFlux endpoint method by putting in the appropriate annotations. Let's go ahead and take a look at transform service. This is basically going to define the apply transform method, which will be called by the transform controller to do the image transform operation. And this is a Spring service. It's got a hardwired, or rather auto-wired field that connects the transform service to the transforms. And you can see if you poke around, you can find where the transforms are defined. They're defined over here. And you can see that this is the signature. You pass in the file name, the transform to apply, and the bytes that correspond to the image. I provided a lot of the code here just because it's kind of complicated and you have to know how to make the right calls to the underlying transforms themselves. So if it's a grayscale transform, you transform with grayscale. If it's a sepia transform, you use a sepia. If it's a tint transform, you use the tint transform. And again, these are all defined over in this little helper file. And the last thing you have to do here is you get everything back and you have to write the code that will return the transformed image within the appropriate DTO wrapper, or data transfer object wrapper. And if you look at the signature for this method, you can tell pretty quickly what that's going to be. And so you'll just have to go over and take a look at transformed image and call the appropriate constructor to make all the magic happen. So those are the main things that you'll need to do for this particular assignment. This is not particularly hard, but what was tricky was getting all the pieces to work. So if you want to poke around and see how we did this, I recommend you take a look at the common folder, which has a model in it, which contains the transformed image and various constants, a cool file called image utils, which does the conversion from byte arrays to buffered images and back and forth and so on. This was very important to get right in order to work properly with Spring. Spring has a little bit of an issue passing around byte arrays or more than one byte array, so we had to play some clever tricks in order to get everything to work. But work it does, and if you implement all the different pieces correctly, then your program should work when you run the tests as well as when you connect to it from the Android client app. Now that we've walked through the specification and skeletons for part 2 of assignment 4, let's go ahead and run the unit tests. As usual, come down here and click on Run the Tests in Java. And as you can see, this goes ahead and starts up a bunch of different microservices, because that's what we have to do in order to run the tests. And then it goes ahead and applies various tests for the different types of transforms that we're doing. As you can see here, all the tests pass, which is good, and that's what you should see when you run your tests as well. So now that we've walked through the specifications, the skeletons, and the unit tests, let's go ahead and put all the pieces together. On the right-hand side of my screen, you can see I've got the IntelliJ project running, the server app containing all the microservices, and on the left-hand side, I have Android Studio running with the image crawler client app. On the right-hand side, I've started all the microservices by clicking Run Microservices here on this button. And if you look up here, you can see I've got 5 microservices running: the Eureka application, the main application, Grayscale microservice, Sepia microservice, and Tint microservice. And we're going to focus in on the main application one because that's the API gateway. On the right-hand side, I've got my image crawler up and running in a window. And what I'm going to do now is I'm going to go ahead and set the configurations to make it work remotely. So what I do is I come over here and I click on the Project Reactor version, and I'm going to make the images come locally, but I'm going to have the transforms done remotely. And you can see here I've turned on all 3 of the different transforms: the grayscale transform, the tint transform, and the sepia transform. So now that we've got that, let's go ahead and download stuff. You can see it's going to start out by downloading the various images that it's got, and then it's going to be sending them out to the microservice for processing, going through the API gateway. And you can see here how the various transforms are being applied. You can see that it's taking a while to do this stuff, but everything's running in parallel, which is a good sign, indicates that things are working as expected. Over here, you can see that there's a bunch of threads that are being set up here to do various things on the server side. And we could poke around here and look at some of the other microservices and see what they're doing, but the main application one is the most interesting one. So at this point, everything's done. We downloaded a bunch of images and then we transformed them. We had 4 threads running here on the client app, and then a bunch of other threads were running here on the server. In this particular configuration, everything's on the same machine, so we're not really taking advantage of distributed computing. However, I do have a large number of cores. I've got 8 cores on my MacBook that I'm using here, and so you can see that things did in fact run in parallel. So those are the results. You can see the filtered images here, different pictures of me and different other things over time with different interesting colors. So hopefully that demonstrates how you can run everything. Make sure you start up the microservices first in IntelliJ, and then start up the app, and when you click the button, it should go ahead and find the way to connect automatically.